Yes, hello everyone. Welcome. So for the past 6 videos, we are seeing previous year solutions of linear algebra, UPSC Mathematics Optional Paper 1, right? So already we have completed 2019 to 2024, right? So if you haven't watched all those previous videos, so I strongly recommend you to watch all the previous videos and then you watch this video, right? Because the previous videos I have explained many concepts that will be very helpful in solving these kinds of problems, right? Okay. So we'll start a 2018 paper. So this paper has surprisingly has only 4 questions from linear algebra for 45 marks, right? Usually you will get 60 to 70 marks that has 6 to 7 questions, but this paper has only 4 questions for 45 marks, right? So I'll finish this 4 questions very soon and then we will move on to 2017 paper, right? Yes. So we'll start our first question. You can see express the basis vectors e1 which is 1 comma 0 and e2 which is 0 comma 1 as a linear combinations of alpha 1 and alpha 2. So very simple problem. So you just have to express this e1 as a linear combination of alpha 1 and alpha 2, and separately you express e2 as a linear combination of alpha 1 and alpha 2, right? Solution. So first what we'll do is we will express e1. First we'll express this e1. So what is e1? So e1 is 1 comma 0 as a linear combination of alpha 1 and alpha 2. So let us say some x1 times 2 comma minus 1 plus x2 times 1 comma 3. These x1 x2 belongs to real number, right? Okay. So we need to find x1 x2 here. So we need to express this 1 comma 0 as a linear combination of 2 comma minus 1 and 1 comma 3. So find x1 and x2. So we have 2x1 plus x2 is equal to 1, and then we have minus x1 plus 3x2 is equal to 0. Right? So solve for x1 and x2. So we have this as first equation, second equation. So let us write the first equation as it is. So 2x1 plus x2 is equal to 1. Now multiply the second equation by 2. So we will have minus 2x1 plus 6x2 is equal to 0. Now add this, you will have 7x2 is equal to 1. This implies x2 is equal to 1 by 7. If x2 is 1 by 7, what is x1? So from 2 we have x1 is 3 times of x2. So 3 times of 1 by 7. So x2 is 3 by 7. Sorry, x1 is 3 by 7. So we have expressed 1 comma 0. We have expressed 1 comma 0 as a linear combination of x1 times 2 comma minus 1 plus x2 times 1 comma 3. This x1 x2 are given by this x1 is 3 by 7 times of 2 comma minus 1 and x2 is 1 by 7 times of 1 comma 3, right? You can check this. 3 into 2 by 7, 6 by 7. So 6 by 7 plus 1 by 7. 6 by 7 plus 1 by 7 is 7 by 7. 7 by 7 is 1. So we have 1 here. 3 by 7 into minus 1 is minus 3 by 7. Minus 3 by 7 plus 3 by 7, which is 0. So our x1 and x2 are correct, right? Our x1 x2 are correct. Now similarly, you have to express e2 as a linear combination of alpha 1 and alpha 2. Now we will express this e2. What is e2? 0 comma 1 as a linear combination of, let us say, some x3 times 2 comma minus 1 plus x4 times 1 comma 3. Now we have to find x4, x3 and x4. So we have 0 comma 1 is equal to x3 times 2 comma minus 1 plus x4 times 1 comma 3. So we have 2x3 plus x4 is equal to 0, and then we have minus x3 plus 3x4 is equal to 1. So call this as 1 and 2. Now solve for 1 and 2. So multiply 2 with this equation. So we have 2x3 plus x4 is equal to 0. So multiply 2 with 2. So we will have minus 2x3 plus 6x4 is equal to 2. So add this, we'll have 7x4 is equal to 2. This implies x4 is equal to 2 by 7. If x4 is 2 by 7, from 1, 2x3 is minus x4. So minus 2 by 7. So we have 2x3. So 2 will get cancelled. So we have x3 to be equal to minus 1 by 7. So we have expressed 0 comma 1 as a linear combination of, so we have expressed 0 comma 1 as a linear combination of, so x3 is minus 1 by 7, 2 comma minus 1, plus x4 is 2 by 7 of 1 comma 3. You can check this. So we can see minus 1 by 72 is minus 2 by 7 plus 2 by 7, which is 0. And here we have 1 by 7 plus 6 by 7, which is 7 by 7, which is equal to 1. So we have expressed this E1, E2 as a linear combination of alpha 1 and alpha 2. Right? Very, very simple problem. So we move on to the next one. So it carries 10 marks. Now second one is for the system of linear equation x plus 3y minus 2z is equal to minus 1, 5y plus 3z is equal to minus 8, x minus 2y minus 5z is equal to 7. Determine which of the following statements are true or false. Very, very simple 11th standard level problem. You just have to solve, you just have to check the consistency for the system of linear equation. Now you can see the system is a given system is homogeneous system, right? So it is a homogeneous system of, so it is a homogeneous system of linear equations, simultaneous linear equations. So first what we'll do is, it is of the form ax equal to b, right? So it is of the form ax equal to b. You know what is a is the coefficient matrix and x is the unknowns, which here is x comma y comma z, and b is the output vector, which is minus 1 minus 8 and plus 7. So first what we'll do is we will form the augmented matrix. So write the augmented matrix. So augmented matrix is 1, 3, minus 2, minus 1. So I hope everyone knows how to solve a system of homogeneous as well as non-homogeneous system of linear equations, right? If you don't know, just go to the playlist. You will refer linear algebra section. Okay. Now a comma b 1, 3, minus 2, minus 1, and then we have 0, 5, 3, and minus 8. Then we have 1, minus 2, minus 5, 7. So we will reduce this to row echelon form. So we have R3 is transformed to R3 minus R1. Already this element is 0, so we don't need to make this as 0. Now this a comma b is equivalent to 1, 1, 3, minus 2, minus 1, 0, 5, 3, and minus 8. And if I subtract this, 1 minus 1 is 0, minus 2 minus 3 is minus 5, minus 5 minus of minus 2. So minus 5 plus 2. Minus 5 plus 2 is minus 3. 7 minus of minus 1 is 7 minus of minus 1 is plus 8. Now we will make this element as 0. So we have R3 is transformed to R3 plus R2. So this is equivalent to 1, 3, minus 2, minus 1, 0, 5, 3, minus 8. So if you add, you will get 0, 0, 0, 0. So which is in row echelon form, right? Which is in row echelon form because first row, first non-zero element, below that everything is 0. Below that means below the corresponding column. Second row, first non-zero element is 5. Below that everything is 0. Below the corresponding column. And third row, there is no non-zero element. So this is in row echelon form. Uh, which is in row echelon form. Which is in row echelon form, and you can see what is rank of A. Rank of A is 2, right? If you consider only this matrix, rank of A is 2, and also what is rank of A comma B? It is also equal to 2. If you consider this 3 by 3 matrix, rank of A is 2, rank is total number of non-zero rows, and when you consider this entire matrix, again rank is 2. So we have rank of A is same as rank of A comma B, both are equal to 2, which is less than number of variables, which is less than total number of variables, which is 3, right? So we have the system is consistent and has infinitely many solutions, right? System, right? Slightly adjust the camera. Okay, which is less than total number of variables. Total number of variables is 3, right? Or which is less than total number of variables. So that means by Gaussian method, the system is the system is consistent and has infinitely many solutions, right? So if you don't know the concepts, you just go to the playlist section, go to linear algebra, you will be finding all the concept videos there, right? Okay. So the system has infinitely many solutions, so it has no solution false. System has unique solution false. The system has infinitely many solutions. This is true. See how simple it is, right? Just still 12th standard level problem. You just have to find the consistency for this homogeneous system of linear equations, right? Okay. So we'll move on to the third problem. Is it clear up to now? Okay. So we'll move on to third one. So actually only there are four problems here. So quickly we can do this. In another 10 to 15 minutes I can do this. Okay. Third one. So that if A and B are similar n cross n matrices, then they have same eigenvalues. So very standard questions. So we will prove that if A and B are similar matrices, we will prove that they have same characteristic polynomial, right? So in order to prove this, we will prove that we will prove that we will prove that if A and B if A and B are similar matrices, we will prove that if A and B are similar matrices, then they have then they have same characteristic polynomial. If the characteristic polynomials are same, then eigenvalues are same, right? Because eigenvalues are the roots of characteristic equation. So if the characteristic equations are same, then eigenvalues will be same. So we prove that if A and B are similar matrices, then they have same characteristic equations, right? Then they have same characteristic equation, a characteristic polynomial. So what is the definition of that is we will prove that what is the characteristic equation for a matrix A? Determinant of A minus lambda I. If I equate to 0, we will have the roots turns out to be the eigenvalue. So this is a characteristic equation for A matrix, and B minus lambda I is the characteristic equation for usually we will find characteristic equation by that formula, right? For 2 cross 2 matrix, lambda square minus S1 lambda plus S2. For 3 cross 3, lambda cube minus S1 lambda square plus S2 lambda minus S3. Instead of that, I'm using definition of characteristic polynomial, which is nothing but you have to evaluate uh, the determinant of A minus lambda I, right? Okay. Now, we need to prove determinant of A minus lambda I is equal to determinant of B minus lambda I. This will give the characteristic equation of B. This will give the characteristic equation for A, right? Okay. Now we will prove this. It is given that, so we'll start the proof. It is given that A and B are similar matrices. A and B are similar matrices. Are similar matrices. What is the definition of similar matrices? This implies there exists an invertible matrix P. There exists an invertible matrix P such that the matrix B can be written as P inverse AP, right? So this is a definition of similar matrices. Two matrices are similar if there exists an invertible matrix P such that B is equal to P inverse of AP, right? Okay. How to find that P at R we will do in concept videos. Um, it is given that A and B are similar matrices. So by definition, there exists an invertible matrix P. There exists an invertible matrix P such that B can be written as P inverse of AP, right? Okay. Now we will start with B minus lambda I, right? Now we will start with B minus lambda I. So we'll start with B minus lambda I, right? Okay. Now I can write this as B minus lambda B minus lambda I, or else can I start with A minus lambda? Anything you can do, right? Or else I'll start with B. I'll start with B minus lambda I. Okay. Now what is B? We know that this B is P inverse of AP minus lambda I, right? So I'll just replace this B to be P inverse of AP, because A and B are similar means there exists an invertible matrix P such that B is equal to P inverse AP. Now this is equal to P inverse AP minus lambda. Can I write this I as P inverse into B? Because this P is an invertible matrix. That means P inverse into P into P inverse is equal to ID matrix, because by P is invertible. By definition, inverse exists, right? Okay. So inverse exists means P inverse into P inverse is equal to I. Now this is P inverse AP minus this lambda is scalar. So I write this as P inverse of lambda P, right? So P inverse of AP, just for some simplicity, I write this as P as I into P, right? Both are same only, right? I into P is P only, ID matrix into P matrix. Now, can I write this as P inverse of A minus lambda I into P, right? I'm just taking P inverse P common here. So, in the left hand side we have B minus lambda I. The right hand side we have P inverse of A minus lambda I into P. Now you take determinant on both sides. Now take determinant. Now take determinant on both sides. Right? Now take determinant on both sides. What we have? So determinant of B minus lambda I is equal to determinant of P inverse of A minus lambda I into P. So by properties of determinant, determinant of AB is determinant of A into determinant of B. So I can write this as determinant of P inverse, determinant of A minus lambda I, and the determinant of P. So determinant of P inverse is 1 by determinant of P, and the determinant of A minus lambda, I will keep this as it is, determinant of P. I can cancel this because determinant of P is not equal to 0, right? And also determinant of P is not equal to 0 because this P is an invertible matrix. So we have determinant of B minus lambda I is same as determinant of A minus lambda I. This implies the characteristic equation. This implies the characteristic equation or polynomial characteristic equation of A and B matrix of A and B are same. The characteristic equation are same, the roots are also same. This implies the eigenvalues of A and B are same. Right? So very simple. You just have to understand similarity of matrices, right? So how to find that matrix P? That you need to know the idea of eigen vector concepts. Okay. Okay. So we will start fourth problem. So last problem of this year. Okay. Let A be a 3 cross 2 matrix and B be a 2 cross 3 matrix. Show that the product AB is a singular matrix, right? So again, very simple proof. So we'll start. See, A is a 3 cross 3. A is a 3 cross 2 matrix. Now we know that rank of A is always less than or equal to minimum of m comma n, right? So rank of A always less than or equal to minimum of 3 comma 2. So we have rank of A is always less than or equal to 2, right? Very simple ideas. Now B is a 2 cross 3 matrix. B is a 2 cross 3 matrix. So that means rank of B always less than or equal to minimum of 2 comma 3. So we have rank of B is always less than or equal to 2. Very simple, right? If A is a m cross n matrix, rank of E is always less than or equal to minimum of m comma n. Okay, so we have these two ideas now, right? Rank of A is always less than or equal to 2 and the rank of B is always less than or equal to 2. Now, uh, now we have, now we have, so to prove this, what we'll do is, now to prove this, now to prove this, now to prove, we will prove that, first we will prove that, to prove this, to now to prove, first we will prove that rank of AB is always less than or equal to rank of A, and we'll also prove that rank of AB is always less than or equal to rank of B. So if I show these two things, then this will follow from this, right? So first what I'll do is we will prove this and then we'll come back to the question. So first what we'll do is to prove. So first what we'll prove is we will prove that rank of AB is always less than or equal to rank of A. So first we'll prove this part, right? Now you can see we will start with we have A to be instead of 3 cross 2. Can I assume A to be some n? Okay, we'll start with here itself. Here, here A is a 3 cross 2 matrix, right? Rank can be what? It can be 2 or it can be 1, right? If it is 0 matrix, that's not possible. So, will A and B a 3 cross 2 matrix, but it can be a 0 matrix also. Okay, so but A can rank of A can be 3, sorry, rank of A can be 2 or it can be 1 or it can be 0 if A is a 0 matrix, right? Okay. Now, if A is, let here A is a 3 by 2 matrix. Now, you consider this example, right? Let us take A to be some 3 cross 2 matrix, right? So 3 rows, 2 columns. 3 rows, 2 column. A1, A2, B1, B2, C1, C2, right? This is A is a 3 cross 2 matrix. Now you need to find the rank, right? Let us say, for example, instead of this, I'm just take some numbers. 1, 2, 2, 4. Just for understanding, I'll just take A to be this matrix, right? I'll just take A to be the matrix 1, 2, 1, 3, 2, 4, right? So this has 2 rows, 3 rows, and 2 column, right? Now if I reduce this to row echelon form, we will have what? R2 minus R1, and then we have this is 0, 0, right? So here you can see the rank for this matrix is 2. Yes or no? Rank for this matrix is 2 because it has 2 non-zero rows. If I take A to be 1, 2, 1, 3, and 2, 4. Now, here you can see the rank is 2, right? For this, the rank is 2. Let us say, suppose if your A is, let us say if your A is 1, 2, 2, 4, 3, 6. Then this A is equivalent to 1, 2, 0, 0, 0, 0. Here you can see this rank of A is 1, right? So the rank of, if rank of A is 2, you can see this A is equivalent to some submatrix of rank 2 and then some submatrix of some 0 submatrix. And here you can see if your rank is 1, then you will have some submatrix of rank 1, remaining will be a 0 matrix. I'll just write it down here. A is a 3 cross 2 matrix. Let us say rank of A is R1, right? Let us say rank of A is R1. Here our R1 is 2 and here our R1 is 1. Then A is equivalent to, after reducing to row echelon form, then this A can be written as some M. This M is a submatrix and some zero matrix where M is a submatrix of rank what? Of rank R1. Yes or no? Where M is submatrix of rank R1. You just look at this example. Suppose if your A has rank R1, then the matrix A after reducing to echelon form will be some M times 0. Here M is a submatrix of rank 2. And here you can see our M is nothing but rank 1 matrix and this is a 2 by 2 matrix. So this A can be written as M0 where M is a submatrix of rank R1. Is this step is clear? So if A is your A is 3 cross 2 matrix, let us say rank of A is R1, then after this A is equivalent to, after reducing to a row echelon form, you will always have a submatrix of rank R1 and then some 0 submatrix, right? Okay. So A is equivalent to some M comma 0. In this example, our M is this 2 by 2 matrix of rank 2 and then this O is uh, two columns, one row, right? This is a zero matrix. In this example, our M is 1, 2 and O is this zero matrix, right? Okay. Now, post multiply. Now, post multiply by, see, A is a, rank of A is R1 and rank of M is also R1. Yes or no? From this example. Let us post multiply by B, right? Now, what this become? This will become AB times some M comma 0 into B, right? Now this matrix, right? This matrix has R1 non-zero rows. Yes or no? R1 non-zero rows. This matrix has R1 non-zero rows because rank is R1, right? So it has R1 non-zero rows. This implies if I multiply R1 non-zero rows with a matrix B, that B has rank R2, the overall product, you just take some examples, right? The overall product will have at most R1 non-zero rows, right? So this has R1 non-zero rows. If I multiply B with this matrix, either the whole can be of R1 row or R1 non-zero rows or less than R1 non-zero rows. Very simple, logical, right? Understanding. So that means rank of this M0 into B matrix is always less than or equal to R1, right? So here you apply rank on both sides. So rank of AB is equivalent to rank of this M0 into B, and you know this rank is always less than or equal to R1. So here we have rank of AB. So what is R1 actually? R1 is nothing but rank of A. So we have proved our first part. Rank of AB is always less than or equal to rank of A. Is the proof is clear? So if I prove the first part, second part is very simple. So rank of AB is always less than or equal to rank of A. Right? You just see this example and then you just compare this with the example. So we have proved that rank of AB is always less than or equal to rank of A, right? Now to prove second part, that is very easy. Okay. So we have proved that, see, we are going to prove these two, right? Okay. Rank of AB is always less than or equal to rank of A and rank of AB is is not equal to rank of B. Okay. Uh, we have proved that rank of AB is always less than or equal to rank of A, right? Now we will prove. Now we will prove. Now we will prove rank of AB is always less than or equal to rank of B, right? So we will prove this. Now we know that rank of AB is same as rank of AB transpose. Yes or no? Rank of A is same as rank of A transpose. Now this is equal to rank of AB transpose is what? B transpose A transpose. Now we already proved that rank of AB is always less than or equal to, let us call this as star. This is always less than or equal to rank of B transpose by star. Rank of AB is always less than or equal to rank of A. Now we know that rank of B transpose is same as rank of B. So we have put the second part. Rank of AB is always less than or equal to rank of B. So we have proved that rank of AB is always less than or equal to rank of A and rank of B, right? Okay. Now A is a 3 by 2 matrix. A is a 3 by 2 matrix. B is a 2 by 3 matrix, right? 2 by 3 matrix. What about the product? What about the product? The product is a 3 by 3 matrix. Yes or no? The product AB is a 3 by 3 matrix. So these two will have 3 by 3 matrix. Now AB is a 3 by 3 matrix, right? AB is a 3 by 3 matrix. If rank of AB is 3 only, this will be non-singular. Yes or no? If rank of AB is 3, it will be non-singular. Yes or no? Determinant will be not equal to 0. If AB is already 3 by 3 matrix. If rank is 3 only, determinant will be not equal to 0. Basic ideas. If rank of AB is 3, then it will be non-singular. But we know rank of AB is always less than or equal to rank of A. And rank of AB always less than or equal to rank of B. Now rank of A is always less than or equal to rank of A is less than or equal to 2. Rank of B is less than or equal to 2 again. That means can I conclude rank of AB is always less than or equal to 2? If rank of AB is 3, it will be singular. This implies if rank of AB is always less than or equal to 2, but we have AB is a 3 by 3 matrix. This implies what? Determinant of AB is equal to 0. This implies AB is a singular matrix. Only thing is you have to prove that rank of AB is less than 3, right? Okay. So we have proved the theorem. So very simple proof. So the only thing is, see, you need to understand, you need to remember this result. If you know this result, rank of AB is always less than or equal to minimum of rank of A, comma rank of B. So if I'm proving this result, because if I use this result directly, I don't know whether they will award 10 marks or not. That is why I'm proving this result. Rank of AB is always less than or equal to rank of A and rank of B. So AB is, we know that rank of A is 2. Rank of B is 2 again. So that means rank of AB is always less than or equal to 2. But AB is a 3 by 3 matrix. So rank of AB is less than or equal to 2. That means determinant of AB will be 0 because rank is 3 by 3 matrix, that is, right? But 3 dimensional. But here it is this. So that means this is a singular matrix, right? Okay. So that's it. So this paper has 4 questions. So we have completed those 4 questions. So in the next video, we will solve this is 2018, right? So the next video will solve 2017 paper, right? So thank you. All the best.